Today we're going to talk about understanding common factors. This deals strictly with Florida Math Standard 6.ns.2.4. We're going to talk about greatest common factor, and the greatest common factor of two or more numbers is the greatest factor shared by those numbers. Now your first question might be, what exactly is a factor? Well, a factor is any integer that divides evenly into a given integer. And an example of that right here is 8 is a factor of 24. And all that means basically is that you can divide 24 rather, evenly by 8. Okay? And the goal of finding this greatest common factor is to find the largest number possible that will divide evenly with no remainder into the given numbers. So we're going to look at two different types of ways we can find the greatest common factor. And our first method, which is probably the one that if you've done this before, you've seen most often, and basically you just list all the factors of each of the numbers and then try to find the biggest one that's in common with all of them. So we have a specific problem that we're going to talk about, and that one says that a baker has 24 sesame bagels and 36 plain bagels to put into boxes. Each box must have the same number of each type of bagel. What is the greatest number of boxes that the baker can make using all of the bagels? How many sesame bagels and how many plain bagels will be in each box? So essentially what we're trying to do is we're trying to find the greatest common factor of 24 and the greatest common factor of 36. So the first step here is to list the factors of each of these. And I just happen to know that the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Okay? So 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, and 4 times 6 is 24. So now the next thing I'm looking for are all the factors of 36. So I know there's 1, 2, 3, 4, 6, 9, 12, 18, and 36. So 1 times 36 is 36, 2 times 18 is 36, 3 times 12 is 36, 4 times 9 is 36, and then 6 times 6 is 36, but we only have to list that one once. Okay? So the next step in this is to identify all the common factors. So here we're going to circle all the factors that are common. So 1 and 1, 2 and 2, 3 and 3, 4 and 4, 6 and 6, 8 and 9, nope, 12 and 12, 24 and 18 are not, and then 36 doesn't have, there's not a 36 in 24. So the common ones are 1, 2, 3, 4, 6, and 12. Now we're looking for the greatest, so the greatest common factor between these two numbers is 12. So GCF equals 12. But that's not all. The number says how many sesame bagels and how many plain bagels will be in each box. Well, in order to find this, if we're going to make 12 boxes, you just divide 24, the number of bagels, sesame bagels, by 12. Okay, so you say sesame equals whatever 12 divided by 20, or 24 divided by 12 is, which is 2. And then the plain is going to be whatever 36 divided by 12 is, which is 3. So you're going to get 12 boxes of bagels, and in each of those boxes you're going to have 2 sesame bagels and 3 plain bagels. So that is using the listing all the factors method. The second method that I want to talk about is commonly referred to as the birthday cake method. Now, you'll see why it's called that here in a second, but we're going to go back to our existing problem where we have the baker. He has 24 sesame bagels and 36 plain bagels. Same exact problem. I'm not trying to make it difficult. So how you do this one is you divide, okay, all the numbers by one number that will give you an even answer. And what I mean by that is with no remainder. And you just continue dividing each new set of numbers until you're left with numbers that you just can't divide evenly. Okay? Then you take all your divisors, multiply them together, and then the answer is going to be your greatest common factor. So that's what we're going to do. So over here to the side of our problem, I'm going to draw this little thing right here, and I'm going to write both of the numbers that I'm trying to find the greatest common factor of, 24 and 36. I'm going to keep that there. So the first thing I want to do is try to find a number that I can divide into both 24 and 36. I want to keep this as simple as possible. So I know they're both even, so I can divide by 2. 24 divided by 2 is 12. 36 divided by 2 is 18. We draw a line again. These numbers are still even, so I know I can divide by 2. 12 divided by 2 is 6. 18 divided by 2 is 9. And I draw another line like that. And you can see this is kind of looking like an upside down birthday cake. That's why we get the birthday cake. It's like a layered cake or a tiered cake. So here I'm looking at 6 and 9. Well, 9 is odd, so I can't divide 9 by 2. So I have to see if I can find another number. Well, they're both divisible by 3. So I write 3 right there. 6 divided by 3 is 2. And then 9 divided by 3 is 3. So I'm going to draw another tier to my cake. Now I need to try to find a number that I can divide both 2 and 3 by. Well, the only one that I can see is, because 2 is only divisible by 1 and 2, and 3 is only divisible by 3 and 1, or 1 and 3. So the only common one they have is 1, and that won't do me any good. So I'm done. So now I take all my divisors, and I multiply them together. 2 times 2 times 3. 2 times 2, we can go ahead and draw it like this and say that's 4 times 3 equals 12. Well, ho, guess what? On our last problem, the greatest common factor was also 12. So nothing changes. We get the same answer. Okay, you would still have to go back and answer this other part where it asks you how many bagels are you going to get in each box. And you're still going to get the 5 bagels, the 2 sesame and the 3 plain. None of that changes. You just use to follow the same steps. So that is the 2 methods that you can use to find the greatest common factor.